Yeah, very good afternoon, students. Today we are going to discuss about the semantic networks. This is a unit 2 concept and which is lecture number 2. And as you know, our open elective is Introduction to Expert Systems. So which is a part of your third semester second BTech SITRC students. Myself, Mr. GV Chiranjeevi Adari. I'm a faculty of Sandeep Foundation, SITRC Nashik. So today we will see what is this semantic networks. Okay, we will consider some examples starting from the basic definitions. Next. So these semantic networks play a very important role or significant role in expert systems. So these are structured representations of knowledge that are used for reasoning and inference. Okay, this reasoning and inference you might come across a discrete mathematical logic in your simultaneous courses. So based upon this particular reasoning and inference of structured representations of knowledge, a large variety of theories, models, methods, and practices, practical applications for creating and utilizing semantic networks have been developed from various branches of academia as well as industry. So, coming to the semantic network consisting of three parts basically. One is a syntax, second one is a specification, and third one is a inference rules. Okay, so what is syntax? Syntax specifies the types of nodes and edges that can be considered, and a specification represents a meaning or semantics that the nodes, links, and entire network can represent. And inference rules. Already we had seen about the role of inference rules in the first chapter. That is, inference engine will make use of some rules that is based upon either if then rules or algorithms or any other predefined rules by the user. So the semantic network consisting of these three, a syntax, specification, and inference rules. Now, let us see how this particular semantic networks will be constructed. See, uh, before seeing this slide, we will straight away go to one particular example. For example, in this one, I think it is visible to you. Okay. So, in this one, so consider an example. Okay. Frosty is a snowman. Frosty is a snowman. A snowman is made of snow. Snow is frozen water. It is slippery and soft. Snow is cold. Ice is also cold. It is also frozen water. But unlike snow, which is soft, ice is hard. Ice is clear in color. So, this is the given facts. Some facts are listed here. So, if you observe, there is a logical relation between all these things. See, Frosty is a snowman. Snowman is made up of snow. Snow is frozen water. The snow is slippery and soft. Snow is cold. Ice is also cold. But ice and snow are different. How they are different? So, snow is also a frozen water, but unlike snow, that is, ice is a frozen water. Unlike snow, the ice is soft and ice is hot. Ice is clear in color. So these things we have to represent. We need to represent these things by some pictorial notation like a graphical symbols. Okay. So in this one, first we will start with Frosty. Frosty is an instance of snowman. Snowman is made up of snow. But what is this snow is frozen water? It is snow is slippery and soft. Snow is cold. All these are properties of the snow. So snow form is water and hardness is soft and texture is slippery, color is white, temperature is cold. All these are properties of the snow. And coming to the ice, ice properties are also listed here. Okay, ice is frozen water. Okay, and unlike snow, the ice is hard, clear. Ice is clear in color. So all these are the properties of the ice. Ice color is clear. Ice hardness is hard. Ice texture is slippery. Ice form is, what is ice form? Water. And ice temperature is cold. So in this way, if we construct a particular diagram which is having some nodes, these are all this frosty, snowman, snow, all these are all known as a nodes. Whereas these arrow marks which are representing between various blocks are either a properties or belongingness or their characteristics. These are known as a links. Clear? Got it. And the arrow mark, the arrow directions uh, will be just indicating the in which direction they are attributes. Yeah, they are attributed. So now in semantic networks, we represent the knowledge as a graph with nodes corresponding to concepts or facts in the problem domain. And the arcs, these arcs represent relations or associations between the concepts. Clear? So now we will see one more example. In the another example, we will take the a canary example. Canary and ostrich. Canary is a bird. Ostrich is also a bird. But canary can sing. Canary is yellow in color. Ostrich cannot fly. Ostrich is having tail. And bird is a animal. Okay, and bird can fly. Bird has wings. Bird has feathers. See, animal. Coming to the animal, the fish is animal. The animal can breathe. Animal has skin. Animal can move. So in this one, how much of information which is embedded in this diagram? This is the major advantage of the semantic network. So we can embed all the knowledge associated in different ways. Different attributes can be embedded into a single picture. Okay, it is semantic network for animal, bird, and canary or ostrich. Clear? So that is described here. So here the properties can be inherited. For example, bird has a properties of fly, bird has wings, bird has feathers. These are the properties which every bird will possess. So ostrich as well as canary can inherit all these properties from their parent classes. Okay. Similarly, animal can breathe, animal has skin, animal can move. So these are the properties of animal. These properties can be attributed or inherited by any type of animal. Clear? So this is another one significant aspect. Now we will go to previous. We had left two slides now. So this is first slide already discussed. The semantic network requires three parts basically: a syntax, specification of or specification of the meaning or semantics that the nodes, links, and entire network can represent. Inference rules. So this is three parts. There's every semantic network will be having. Now coming to this one, these semantic networks are useful in the knowledge representation. Okay, so basically the data structures representing semantic networks comprise at minimum nodes that are referred to as concepts. The nodes, whatever the nodes we had seen just now, these nodes are known as a concepts. Okay, and edges between the concepts. What are the edges between concepts? This arrow marks. The arrow marks are arcs. Anything. There is no need of this particular rectangular arrow. Okay, we can draw some arc also. Okay, and concepts are abstract representation of the ideas. See, concept. What is a concept? Concept is an abstract representation of idea or thoughts or units of knowledge, and it can also be a meaning that people conceive in their minds. Concepts can also be referred to as a objects. Examples for the concepts are social network analysis, collaboration, community of practice. Okay, when concepts have representation in natural language, the respective word or sequence of words are used as labels for nodes in semantic networks. What about the links? If the links in the semantic networks are typed, the link type explicates the nature of the relationship between the correct connected nodes. Otherwise, the links can represent or establish some meaningful association between the pair of concepts. For example, in this one, snow and water. So, what snow is a form of water. There is some meaningful relation between these two. Okay, so that is the thing. So this is just a description about the semantic network, how the semantic network can be represented as a data structure. In the data structure, we will make use of concepts, okay, concepts and links. The link information, whatever the link information, that is basically consisting of some type of some type of uh, relation between the concept as well as concepts as and one concept to another concept or concept and the attribute like that. Clear? Next is we will see how to extract the meaning from semantic networks. The meaning of a concept is of the network that is activated when the node of interest is triggered. So in this case, the meaning extraction will be having three cases. Either we can predict, either we can predict the fact or predict the relationship between. So semantic network data can be used to forecast set of concepts that will be evolved when a certain node is activated. Okay, disambiguation. Disambiguation is nothing but whenever we are making the clustering, whenever we are making some clustering, then the ambiguity will be eliminated generally. And from the semantic networks, there may be a possibility of summarization. So, whatever the concepts that an ego network can serve as a technique, okay, that is essence of some input data in concise and structural form. So, in this way, the meaning of the meaning can be extracted from semantic networks. Okay, next. Semantic networks for modeling and mind semantics are also used as a proxies for cognitive models and mental models. Okay, this is one of the key aspect of the role of semantic networks in the knowledge engineering. So coming to here, the knowledge of individuals and groups about a certain topic, the knowledge of groups is also referred to as a social knowledge and can represent culture. The perceptions that the people have in their minds and use make use sense of their environment. So these two are majorly represented by the semantic networks. Common methods for constructing and extracting mental models are file sorting and analysis of natural language text data, such as interviews. For example, if you consider an interview, so some different aspects of data will come to you. Okay, the personal data may come to you, the professional data may come to you, and some interpersonal characteristics also you can extract. Okay, so this type of uh, mental model, this type of interviews will be a part of extracting mental model or constructing a model simply. Once model is created, individual mental models are examined. They are compared and combined with network analytical techniques in order to identify the meaning and evolution of the knowledge of individual groups. This technique has been used to assess the situational awareness and shared understanding of events or tasks in remote work teams whose memberships use collaboration technologies to coordinate their decisions and actions. Okay, so this is basically the application of the semantic networks simply. Okay, we can create a cognitive models and we can create a mental models. Okay, see next semantic networks for knowledge management. How the semantic networks will be contributing for the knowledge management. Once semantic networks are constructed, so the network can be constructed from the given facts. You can use nodes, you can use relations as a arrows, okay, and you can construct a network. And that semantic network that is constructed should be stored in the relational database, RDBMS, like that. They can be used for various data management tasks such as search, retrieval. Search means to find something. Retrieval, whatever the uh, item which you can find, that should be retrieved. Structural cues, question answering and definition acquisition, etc. Semantic networks can also be visualized. As we seen in the previous diagrams, these are all networks which can we can visualize simply. From the particular arrangement, we can have some idea about it. That is visualization. Okay. Since most network visualization techniques have no syntax, the resulting images are appropriate as heuristic tools only. Okay, so here coming to this semantic networks, mind mapping, concept mapping are the methods that facilitate individual and collective learning processes, brainstorming, and the organization of the knowledge, etc. These methods are performed in manual and computer supported fashion. Okay, next hypertext. Hypertext is a dated, computer supported method for personal text and data management. So, this hypertext can be useful for semantic network representation in the form of a knowledge. And these respective tools, which are corresponding to hypertext, can be used as a open source and extensible, enable users to annotate chunks of data, other electronically available information such as multimedia content with codes, user defined links, etc. between the data elements and codes. By constructing such structured information, users make implicit relations in the data explicit. Now, coming to the semantic networks and how they can be employed in the expert systems. We can use Bayesian inference semantic networks. They are constructed by subject matter experts to model a certain particular phenomena or domain, are also used for Bayesian inference. This application domain of semantic networks combines structural data with statistical learning. Okay, so in the next clauses, we will see what is statistics, what are the statistics associated with the expert systems. In expert systems, the statistics associated are the probabilities theory, probability theory, Bayesian networks, certainty factors. Okay, these are the statistics involved. So, the semantic network combines structured data with statistical learning. So, in such networks, the concepts are random variables and the edges indicates conditional probabilities, uncertainties, and casualties. The resulting networks are also referred to as a belief networks, influence diagram, procedural, semantic network, and probabilistic graphical model. Regardless of the name, these models are used by assuming that the latent structure that the semantic network represents has generated the observed data through a probabilistic process. Given the observed data, the latent structure is then inferred to Bayesian inference. Got it? So now we are having, while representing the this particular semantic networks, we generally go for the graphs. It is one type of graph. This is known as a conceptualized graph or conceptual graph. The conceptual graph is a finite. The number of elements are finite. Connected graph. We are having two types of graphs: connected graphs, disconnected graphs. Bipartite graph. The nodes of the graph are either concepts or conceptual relations. Anything may be possible. Concepts are represented as a boxes and relations are represented as a ellipses. See, for example, person, many person. Person, person is Mary. Sorry, we are taking two persons, Mary and John. Mary is agent. See, object, the uh, Mary is giving a book to the person John. Mary gave John the book. So, what is the object here? Book. So, the book is a concept. The conceptual relationship is object. So, the give is a verb, action. Who is giving? Mary is giving, agent. And who is recipient? The John is the recipient. Okay, we can represent like this. This is known as a conceptual graph. So in this, all the elements are finite, connected. Okay. Similarly, we will see one more example. So in this example, so it is an alternative. The semantic networks are basically an alternative to the predicate logic. You know predicate logic? In mathematics, we are having a propositional logic and a predicate logic. So in the predicate logic form is belonging to this semantic network representation. The idea is that we can store our knowledge in the form of a graph with nodes representing objects in the world and arcs representing relationships between the objects. So for example, if you see this particular diagram, so we will start with uh, Tom. Tom is a Tom is Tom's color is ginger and Tom is owned by John. Here John is a person, Tom is a, that is, cat, his cat. Okay, and the Tom caught bird. Bird is a animal, but cat is a mammal. Mammal, mammal is always an animal. Mammal has fur, but cat properties. Cat, what it is attributing? Attributing. Cat is sitting on mat. Cat likes cream. Okay, like that. So these facts can be represented like Tom is a cat. Tom is a cat. Tom caught a bird. Tom is owned by John. Tom is ginger in color. Cats like cream. The cat sat on the mat. Cat is a mammal. All these are the logic. Whatever the information embedded in this particular semantic net, that can be retrieved like this. We can write like this. All these are combined into the form of net in this manner. Clear? Next, coming to here, inheritance. We need to come across the term inheritance. So inheritance is what? Here, for example, cat is a mammal. Okay, mammal is having a fur, and it is also it is a animal. Mammal is a animal. So cat is having a fur. Since mammals are having a fur, cats can also having a fur. Similarly, if the Tom is a cat, the Tom is having fur. So this is the property of semantic nets. The inheritance can also be uh, constructed. Okay. So this is the explanation. What is in which what it is inherited from the other class. Clear? Next. So coming to the conceptual graphs, already we had seen what is the conceptual graph. It is having a it is a connected graph having a finite number of elements or finite number of objects. Okay, which will include a concept type proposition that takes a set of conceptual graphs as a its referent and allows us to define relations involving propositions. Propositional concepts are indicated as a box that contains another conceptual graph. For example, here Tom is a person. Person is a Tom. Tom believes the object. What he believes, Tom believes that this particular proposition. What is the proposition? Johnny likes pizza. He believes that Tom believes that John likes pizza. John likes pizza can be represented as a one proposition, whereas Tom is a agent here. Okay, he is experienced, or his experience is he is having faith in this particular journey. Clear? So that's why these propositional concepts can also be indicated like a box. This is also belonging to the conceptual graph. Next. So in this class, I had given you a basic idea about the semantic networks. How the semantic networks will be embedding the or will be visualized as a knowledge bases. Clear? So once you go through this PPT as well as this recorded session, and if you are having any clarifications, always you can reach to me, and thanking you. We will end up this session. Thank you.